Factors to consider when buying supplies. Quality. The quality of supplies is crucial as it directly impacts the quality of the end product. Look for suppliers who provide consistent quality and have a reputation for delivering reliable products. Conduct quality assessment, request samples, and check for certifications or accreditations to ensure compliance with industry standards. Reliability and delivery time. Second, evaluate suppliers based on their track record for reliability and on-time delivery. Late deliveries can disrupt production schedule, leading to inefficiencies and potential customer dissatisfaction. Consider the supplier's capacity, proximity to your operations, transportation options, and the ability to meet your demand consistently. Cost. Third, cost. Consider the supplier capacity, proximity to your operation, transportation options, and the ability to meet your demand constantly. Third, cost. While cost is an important factor, it should not be the sole determining factor. Look for a balance between quality and cost. Consider the total cost of ownership, including purchase price, maintenance costs, product lifespan, and potential hidden costs like shipping, storage, and disposal. Negotiate price and terms to ensure competitiveness without compromising quality. False supplier relationship. Building strong relationships with suppliers is beneficial for long-term success. Evaluate the responsiveness, communication, and willingness to collaborate. A good supplier should be open to discussing requirements, addressing concerns, and providing technical support when needed. Consider the supplier's financial stability and the ability to scale with your growing needs. Fifth, sustainability. Consider the environmental impact of the suppliers you purchase. Look for suppliers who prioritize sustainability, ethical sourcing, and environmentally friendly practices. Assess the adherence to environmental regulations, their waste management strategies, and whether they offer eco-friendly alternatives or recycling programs. Assess the adherence to environmental regulations, their waste management strategies, and whether they offer eco-friendly alternative or recycling program. 6. Compatibility and integration. Evaluate how well the suppliers integrate with your existing operations, machinery, and system. Ensure compatibility with your production process and any specific requirements or standard. Consider the ease of integration, training needs, and potential disruptions during the transition phase. Consider the ease of integration, training needs, and potential disruptions during the transition phase. 7. Risk management. Assess the risk associated with the suppliers and the potential impact on your operations. Consider the supplier's contingency plans, backup options, and the ability to handle disruptions such as natural disasters or supply chain interruptions. The supplier's contingency plans, backup options, and the ability to handle disruptions like natural disaster or supply chain interactions. Diversify your supplier base to minimize dependency on a single source. In innovation and continuous improvement, look for suppliers who actively engage in research and development, innovation, and continuous improvement. Suppliers who offer new technologies, process enhancement, or cost-saving solutions can contribute to your operational efficiency and competitive advantage. 9. Scalability and flexibility. Consider the scalability and flexibility of suppliers to meet your evolving production needs. Ensure that the supplier can accommodate volume changes, product customization, and new product introductions. The scalability and flexibility of suppliers to meet your evolving production needs. This flexibility is essential for managing demand fluctuations and adapting to market changes. Regulatory and legal compliance. Verify that the supplier comply with applicable laws, regulations, and industry standards. Consider any legal or compliance risks associated with suppliers, such as intellectual property rights, safety requirements, or import-export regulation. Type of product: intermittent, job, batch, continuous mass process assembly. In intermittent manufacturing system, the goods are manufactured especially to fulfill orders made by customers rather than for stock job and batch. One of the units of a product are produced job production. One of the units of a product are produced to customer requirements within the given time, within the price fixed prior to the contract. like hairdressers, painting and decorating, film production, large construction projects, permanent tattoo. Raw materials and equipment, like fresh stencil, ink, tattoo machine, and mixture learner supplies. Batch production is a manufacturing method where a limited quantity of each type of product is authorized for manufacture at a time. Manufacture of a limited number of products produced at periodic intervals and stored in warehouse as finished goods, like medicine, health supplements, baked goods, electrical goods, and ice cream. Raw materials is brand of dairy products, sugar, flavors, additive, and aid. Job production is one of few units of product are produced to customer requirement within the given day amid with the price fixed prior to contract. Batch production is a manufacturing method where limited quantity of each type of product is authorized for manufacture at a time. Manufacture of a limited number of products produced at periodic intervals. Manufacturing process: branding the mixture, pasteurizing to kill bacteria, homogenizing to produce a uniform texture, cooling and resting to brand flavors, flavoring the ice cream, freezing to soft consistency, adding fruit and sweetened chunks, packaging and binding the finished product. Hardening. In continuous manufacturing system, the items are produced for the stocks and not for specific orders. Before planning manufacturing to start, a sales forecast is made to estimate likely demand of the quantity of the product. Continuous has mass process and assembly. Mass production, flow production or repetitive flow production is the production of large amount of standardized products on production line. Mass production is capital intensive as it uses a high proportion of machinery in relation to workers. Mass productions are usually organized into assembly lines. The assembly parts by on a conveyor or if they are heavy hung from an overhead monorail. Mass production examples like canned food, hands, baked beans, colors, cornflakes, Mars bars, Ford cars, toothpaste. Toothpaste manufacturing raw material like fluoride, flavor, water, sweeteners by the precipitative. Manufacture process, weighing and mixing, filling the tube, packaging, and shipment. Process production involves a series of processes which raw materials go through. The end result is a large quantity of finished product. Process production tends to be quite capital intensive, requiring significant investment in production machinery and facilities. It involves a series of processes which raw materials go through. Process production examples like oil refining, cement, natural gas, and vodka. Raw materials like vegetable, grains, flavorings, malt, meal, yeast, water, manufacture process, mash preparation, sterilization, and inoculation, fermentation, distillation, and ratification, water adder, and bottling. Assembly production. Assembly lines are designed for a sequential organization of workers, tools, or equipment and parts. Assembly lines are designed for sequential organization of workers, tools, or equipment supply. The motion of workers is minimized to the extent possible. All parts and assemblies are handled either by computers or motorized vehicles like forklift gravity with no manual tracking. Heavy lifting is done by machines such as overhead cranes or forklift. Each worker typically performs one simple operation. Motor vehicle assembly. Electrical products assembly. Raw materials process steel, fiber, aluminum. Manufacture process, stamping, welding, painting, assembly, inspection. Just-in-time production stands for just-in-time, which is a production and inventory management strategy aimed at minimizing waste and improving efficiency in manufacturing and supply chain process. It's a lean manufacturing approach that involves producing and delivering goods or services precisely when they are needed, neither too early nor too late. The key principle behind just-in-time is to eliminate or minimize various types of waste, including defects, overproduction, unnecessary transportation, waiting times, excess inventory, unnecessary motion, and over-processing. By doing so, just-in-time aims to achieve a more streamlined, cost-effective production system. Under a just-in-time system, materials and components are ordered and delivered in small quantities, precisely timed to arrive exactly when they are required for production. This approach helps reduce inventory holding costs and the risk of obsolescence. This approach helps reduce inventory holding costs and the risk of obsolescence. Just-in-time also emphasizes close collaboration and communication with suppliers to ensure timely delivery and high-quality inputs. Just-in-time also emphasizes close collaboration and communication with suppliers to ensure timely delivery and high-quality inputs. Implementing just-in-time requires careful planning, coordination, and a focus on continuous improvement. Involve techniques like demand-driven production, combined system for visual control and signaling, frequent and small batch production, and a strong emphasis on quality control and process efficiency. Just-in-time principle having widely adopted in various industries, including manufacturing, logistics, and service sectors, to achieve operational excellence and enhance customer satisfaction by delivering products or services just-in-time to meet demand. Just-in-time is a production and inventory management approach that aims to reduce waste, increase efficiency, and improve overall productivity. It originated in Japan, gained popularity in 1970s. Just-in-time has revolutionized manufacturing and operation management by emphasizing waste reduction, efficiency, and continuous improvement. It has provided the organization with a framework to optimize the process, enhance quality, and respond effectively to customer demands. Key aspects in development of just-in-time like Toyota production system, Taichi on-hold and Shigeru Shinko, lean manufacturing and benefits and principle, global adoption, challenge, and criticism. So, Toyota production system. The development of just-in-time can be attributed to the Toyota production system, which was developed by Toyota Motor Corporation. TPS, Toyota production system, aimed to eliminate waste in manufacturing process by adopting a pull system, where production is based on actual customer demand rather than forecasted demand. This TPS emphasizes continuous improvement, employee improvement, and elimination of excess inventory. Taichi, owner and engineer at Toyota, is often regarded as the father of just-in-time. He introduced several key concepts like Toyota production system, Kanban, visual signaling system for inventory control, and the concept of eliminating waste known as MUDA. Another key figure in just-in-time development contributed to the system through the development of single-minute exchange of die, which focused on reducing setup time for machine. Single-minute exchange of die focus on reducing setup time for machine. Lean manufacturing. Just-in-time is often associated with the broader concept of lean manufacturing. Lean manufacturing extends the principle of just-in-time beyond production to all areas of an organization, including supply chain management, procurement, and customer relations. It emphasizes an elimination of all forms of waste, including overproduction, waiting time, unnecessary inventory, defects, and excessive motion. As emphasizes the elimination of all forms of waste, including overproduction, waiting time, unnecessary inventory, defects, and excessive motion. Benefits and principles. Just-in-time aims to achieve several benefits, including reduce inventory holding costs, reduce inventory holding costs, increase production efficiency, improve product quality, shorter lead times, and increase customer satisfaction. The key principles of just-in-time include just-in-time production, continuous flow, waste reduction. The key principles of just-in-time include just-in-time production, continuous flow, waste reduction, standardization, employee enforcement, and close relationship with suppliers. Global just-in-time has been widely adopted by organizations around the world across various industries. Its principles have been applied in manufacturing, healthcare, logistics, and service sectors. Many companies have successfully implemented just-in-time systems to streamline their operations and improve their competitiveness. Challenge and criticism. While just-in-time offers numerous benefits, it also has challenges. Firstly, it requires a high level of coordination and synchronization between suppliers, production process, and customer demand. Second, it can be disrupted by unexpected events like supply chain disruptions or fluctuations in demand. Third, it has faced criticism for its vulnerability to disruptions, lack of flexibility in handling unforeseen concerns and potential negative effects on supplier relationship and employee morale. Just-in-time is a production and inventory management approach that aims to minimize inventory carrying costs by receiving materials and producing goods or services just in time for customer demand. Production, on the other hand, is the function responsible for producing finished goods for an organization. The relationship between just-in-time and production is crucial because production plays a significant role in supporting the successful implementation of just-in-time principle. Just-in-time and production are interconnected in achieving operational efficiency, minimizing waste, and optimizing the supply chain. Production professionals play a crucial role in selecting a